Yep, everything looks great.
Okay, so again, I'm excited to be with you all. My name's Nolan Doyle. There's a bit.ly there. I think Bethan made a different one as well. She's going to throw in the chat, but that will take you to a detailed version of our agenda in a Google Doc, and as well as some resources. So I'll kind of reference that throughout today's presentation, and that will be yours to keep and come back to as you continue learning more and getting more comfortable with. are designed to make that progression kind of seamless for students. So, you're going to see, if you look in the scientific calculator, you're going to see a lot of similarities with the four-function calculator. It's going to be expanded a little bit. And similarly, when we jump to the graphing calculator, a lot of those same features, a lot of the same ways you use the calculator are going to be there. So hopefully that transition is easy for students. When you go to Desmos.com, you can create an account. If you're just using the four-function calculator, you really don't need to. The account at Desmos.com would help you save graphs in the graphing calculator that might be pre-made graphs. So I've actually, if you've opened up that agenda, I'll be coming back to this, but there are at the end just a couple graphs that I saved from the graphing calculator that might help on some of the questions as far as supporting students learning it. Obviously, then they can't use it to work the problem, but as you're introducing topics, you could still make use of that graphing calculator. So I saved a couple, was able to do that because I have an account through Desmos.com. You could also then use that account for the activities at teacher.desmos.com, as I mentioned earlier. So at this point, I'm going to kind of jump into the basics of the four-function calculator. So I'm going to go ahead and jump to Desmos.com. And when you get to Desmos.com, one way to get to the four-function calculator is to click on the tools, and you can click on the four-function calculator here. All right, now you don't want to make use of this calculator though, because the North Carolina one is slightly different. So when you go to Desmos.com, you can go to, instead of tools, go to resources and assessments. Okay, resources and assessments. And that's where you can click on your state, and you can look at, there's a PDF that shares the differences between the standard calculator and the testing calculator that your students will have available to you. So that's why you want to go to the one that's specific to North Carolina, because you actually have two extra features that we'll see: converting decimal answers to fractions and a fraction button that's not available. All right, so again, to access this, you can go to Desmos.com, resources and assessments, and then right here are your specific calculators to North Carolina, the four-function, scientific, and graphing. And I also linked these directly in our Google Doc. So the general four-function calculator is there, and then the is Desmos on your test. You could click directly here to open that, as well as this will take you to the actual calculator. So if you aren't able to go through Desmos.com, or you just want to get there a little bit quicker and then bookmark that for your use, that should get you to where you need to be. And you know it's the North Carolina one because it's green at the top, right? Grades 3 through 5 version, and it has your state name there.
And I'll just interject for just a moment. The reason we have this very special calculator just for North Carolina is a result of Desmos being a really great partner, and elementary school teachers across the state during a webinar like this one several years ago were saying, we really need a fraction decimal button. We really need the ability for kids to enter in fractions and to go back and forth between fractions and decimals. And Desmos built that button for North Carolina, and then several other states opted into using it. So just a quick plug for how responsive they are, how they work so very hard with us to make sure that we have the product that teachers and kids need to be successful.
Yeah, and that's great. It's like you said, it's kind of rare too that there are versions that you guys get added features. So that was pretty cool. You can see that fraction button here. If I go back to the standard version, it's not there. Okay, and so that I'm going to go ahead and close that one just so we don't come back to it. But we want to be using that North Carolina version as you use it and as you use it with your students. So just some basic functionality of the calculator. I'm going to start clicking. We have everything we have on our screen here, the on-screen keypad. So I can just start doing some calculations. One thing I like is I don't have to push anything for that answer to appear, right? So as soon as I put in something like 9 times 3, I start to get that answer. If I put in another operation, it's going to give me an error message. Another thing I like is that error messages are pretty helpful. Sometimes with calculators, especially maybe handheld ones, you don't necessarily get specifics as to why there is an error. So this is telling me I need something on both sides of that subtraction symbol. So I can continue clicking, and it's going to update that answer to the right here, that output. If I want to move to another line, I can hit this blue button here. And I can continue doing some operations. One thing you might notice with the square root here is I continue to put in operations. It's still underneath that square root symbol, under that radical. So I can get out of that two ways. I can just click out to the right. And I can also use, you can't see me do this, but I'm on my keyboard. I can use the arrow buttons left and right to get out of that square root symbol. So that's just something to note and help students with as they're learning the calculator. Continue to hit enter. I can also use my keyboard and hit enter. As we put in the fraction button, we can see we can put in our numerator, and then I can click or arrow down to the denominator, and then click or arrow out of the denominator, out of the fraction completely. So I can go over here and now start to do some operations. So that's that fraction button. Again, that is available to you in the North Carolina version and your students. And then this is the convert to fraction button that is not usually there in the standard four function calculator. So as we get this decimal answer, I can toggle back and forth between the improper fraction, so it will not make it a mixed number, but the improper fraction and the decimal answer there. The other thing we can look at is this X right here. So I can delete one character at a time. I can also clear. So this clear button, the first time I hit it, it will clear this whole line. So this line that I'm on right now, it will clear that entire line. And then notice it now says clear all. So after I clear one line, if I want to clear the entire calculator, I just click that a second time and I've got a fresh start. If I do that by mistake, these arrows are my undo and redo buttons. So whoops, I didn't want to delete everything. Let me undo. I can keep going, right? I can keep undoing and keep going back to wherever I was, and I can redo. So you can always get back to where you are no matter maybe what you push. The other thing you'll notice is as I'm doing more lines, okay, get another calculation in there, hit enter. All these lines are saving above, so I can scroll back up. Not only can I view them, but I could edit them again. So I don't need to, if I wanted to go back, maybe a student was working a problem and you want to say, well, what did you do? What did you put into the calculator, right? They can scroll back up. We can look at it and maybe we need to edit their thinking a little bit. And maybe they need to make some changes. So they could just go back up and type directly into that line. And they could get their result, their answer within that line. We don't have to bring it back down to the bottom. So I think that's something you don't typically see maybe in a four function calculator that I really like. So we scroll back to the bottom, click down here, and make use of the answer key. So this right here is going to pull the answer from the previous line. So 6, and then I can continue my calculations with that. Okay, you'll notice the division symbol will show up just as you see it here. And then you still have, you could do division with the fraction button as well. So I can hit enter here. Maybe I even want to put the answer in a numerator. I could do that. I can put it within the fraction. And notice it's now pulling this one. And I like that it pops up right here too, right? So I can see the number it's actually using as the answer. It just doesn't stay ANS, which is great. I could also go back and edit this line. So as we saw before, I can go and I can continue to edit this line and recalculate. And as I do, it's going to update the answer here, right? So as I change these numbers and this answer changes, it's going to change with the answer that's down here. There's that convert to fraction button again. There we can toggle back and forth to that improper fraction and the decimal form. All right, so we've gone through some of the basics, where to get to the calculator, specifically the North Carolina version and what those differences are. And then I did want to show, and this is linked in your agenda as well below what I just highlighted, where you can pull it up within the testing application. So you can expose your students not only to that testing version of the calculator, but what it will look like within the actual test. So I believe I go to released items. And I'm going to go to the end of grade level. And let's just pull up 4th grade. And then I'm going to do a lot of clicks just to get through the samples and that first section where calculator is not active. And finally into the second section, where now they have this icon in the upper right where they can pull up that calculator and have full access to everything I just showed you. So that fraction button and also that convert to decimal, convert to fraction toggle with all the other basic features. So great opportunity again before students are actually on the test that they get really familiar and comfortable with what things are going to look like. So that's not brand new to them. They can really focus on the content and the problems. A couple other things, I just pulled a few questions just to show some of those features again. What I liked about this question that I saw, I forgot which grade level this was, but a lot of times you don't always see in the calculator the same symbols and representations and notation that you do within a problem, or in this case, the answer choices. So in this one, there's a lot of multiplication in here. There's parentheses, there's fractions. Everything is formatted the exact same in the calculator. So there's consistency for the student to see with what they're seeing on the test and what they're seeing in the calculator, which I think is really, really nice. Someone again who taught is teaching high school, like when we have the TI handheld calculators, a lot of times what they're seeing on those handhelds is not the same thing they're seeing within the problem. So as you enter in, if I clear everything out again, I hit that clear all button. If I start typing in that problem, it's all those symbols and all that notation is going to look exactly the same. One thing I'm doing too that I'll make note of is I'm using my keyboard. And so like multiplication, if I don't want to click on screen, I'm just using Shift 8 to get the multiplication. So that's just kind of a lot of times I enter more things in with my keyboard. That makes it a little bit more quicker for me and your students, depending on how good they are with the mouse pad or whatever device they might be using. If it's touchscreen, it might be a little bit easier, but it might be easier for them to use their keyboard. Another thing I like is it's already kind of ghosting in this closed parenthesis. So it's again, students aren't going to get an error message, right? Because they forgot to close a parenthesis or something silly like that. So we want the calculator to work, right? We don't want students getting error message. We don't want students to get frustrated on small things like that. So I think the design is really great as far as trying to make sure it's working for the students the way they want it to. So get that last fraction in there. And I can just arrow. What I'm using again is on the keyboard, my left and right arrows to go back since this is such a long line. And I can double check I've entered everything in the way I want to. And that's going to match again in this specific question, what we had. I think it was choice D. Here's an example of just using fractions. So I wanted to use this question to model how we want to enter in those questions or those fractions for this question. I can clear out everything in the calculator. And we needed to put in a mixed number. So I just type in my mixed number and then, or my whole number, and then I'm ready for the fraction part of my mixed number. And it was 1. I can arrow down or click for the denominator, 1/8. Arrow to the right or click to the right to get out of the fraction, to get my subtraction symbol. Put in my whole number of 14, ready for my for my fraction part of the mixed number, 3/8, and I get the 6.75. Now I can toggle to that improper fraction. So the only thing we have to be aware of and be ready for is that, right, for our students, it's not going to give them that mixed number, which the choices are. So, several options of what you can do. You can just put in each of those mixed numbers and see which one gives you that same improper fraction. We could also maybe just focus on the fraction piece of it, right? So we know the whole number is going to be either 6 or 7. If we just wanted to focus on the 6/8, right, we could put that in and see what decimal that gives us. And notice that it's going to match there. So 6.75 is the same thing as 6 and 6/8. And then there was one more fraction one. So just seeing, I'm putting in the 1/2. And then we were going to multiply by the 2/3. It's given to us as a decimal. We can toggle to that fraction, match it up with our answer choice there. And then this question is asking students to look at some patterns and see which ones or how many numbers match, how many numbers they have in common. So two different patterns, one starting at 3, increasing by 5. The other one starting at 39, decreasing by 6. So just wanted to use this question of how they might, develop this list of numbers that they need to compare using the calculator and some of its features. So go ahead and clear everything out. So one way is they can start with 3, right? And they could add 5, hit enter, use that answer key, +5, hit enter, +5, hit enter, and keep going. Whoops, we gotta make sure we put the answer in there. And they can always scroll back and get that list. So they can go down the screen and see that list of numbers 8, 13, 18, 23, and so on. The other thing they could do is just stay in one line, right? So we could just have 3 and we could add 5. They could jot down that number, add a +5, jot down that number, +5, jot down that number, and then just work similarly the other way, starting at 39 and maybe subtracting 6 over and over again. So being able to get those answers, I think, in real time, like it's updating on every keystroke. So as I hit -6, I get my result. -6 again, get my result, and always go back if I need to. Or make use of that answer key and see those previous lines, I think is helpful. All right, so at this point, going to look and kind of transition a little bit. We've seen kind of the basics, seen some things of how it fits in with a few of the test questions. But I was going to check in with Beth just to see if anything's popped up in the chat or anything we want to go over before I transition to talking about instruction a little bit more.
Well, see, you have done such an amazing job that I have been able to answer all the very, very minor questions that have popped in. So I will continue to monitor the Q&A if anybody has questions, but for now we're good.
Awesome. Okay, so um, as we talk about Desmos for instruction, we're going to kind of do it through the lens of open questions. So when we talk about open questions, we're making questions that are accessible to all students. We want to give multiple entry points depending on their background. So that just that idea of differentiation, maybe like that low floor, high ceiling type of question. So no matter where students are, there's an entry point for them. We're going to encourage diversity. So there's going to be multiple paths and or solutions. So by doing that, we're going to allow students to have ownership of the problem and kind of take the question in a direction that best fits their understanding. So as we go through these types of questions, and then we'll fill in how does the calculator support these types of questions? What does the calculator use look like for the student? And what does the calculator use look like for the teacher as you go through this type of instruction, these types of questions? So to start just thinking about what an open question is, we've got the question on the left would be a closed question. Find the product of 9 and 8, a pretty straightforward, okay, we're going to multiply that and we're going to come up with the one answer. We can change that into an open question by saying the product of two numbers is 72. What could the two numbers be? So just reflect for a second on kind of the type of thinking that each requires. And more importantly, for me, with open questions, what kind of discussion can occur after asking these questions? I think there's very little discussion and there's very little thinking for the student that takes place after a closed question. Whereas there are lots of opportunities for deeper thinking and extending thinking as we discuss the question on the right, which is a more open question. We can also think about the role of the calculator in this type of question. So as we make this question open, right, we have multiple ways to be correct. We have a lot of different ways to answer that. And so we can start to use the calculator, not just for the student. Maybe we don't even want the student using the calculator here. We want them to be working on their computational fluency. But I, as the teacher, could be displaying student responses. And I could be displaying them in ways that maybe show some patterns and displaying them in ways that might allow or encourage students to make some connections, right? Whether it's connections within the multiplication or within the division or across the two, right? How are we connecting the multiplication and division in this problem? How do those two relate to each other? So that's one thing I kind of see that I want to plant is that the calculator can be a really important tool, really valuable tool in displaying student thinking, and also displaying it in a way that shows patterns and displaying it in a way that helps students make connections and develop that number sense. So some strategies to create open questions. What we just did is we begin with an answer statement, and then we ask for a possible question. So that's what we did here, right? We gave them the answer of 72 and asked them for the question, what would the numbers be to get those to multiply through? Here's another example of how we might change a question, a closed question, into an open one in that method. So instead of saying what combination of coins Melanie has, we tell them the value of the coins. And then we ask the students for the combination. Again, I think the discussion here is really, really important because we can really extend this conversation. We can put wrong answers up. And then all of a sudden you've got students checking each other's answers. So, certain students said, this is the combination of coins. Do we agree? Do we disagree? And all of a sudden this one question has really turned into a bunch of different problems that you've got your students working. And they're probably more invested because it could be their combination that's up there, their answer. It's their peers' answers that are up there. So we might have some healthy debate there. We might have some disagreement and students having to justify their answers. So there's a lot more value in the discussion, I think, with this open question here than that closed question. Another example of that is here where we're not giving them the dimensions of this rectangle, and we're actually even taking it a step further. We're not giving a specific area or perimeter for this one. We're just kind of using some softer language, which is our next strategy. So we're kind of combining these two strategies here, but just create the dimensions where the area of the rectangle is greater than the value of the perimeter. Okay, and then we can ask what's the greatest difference you could find? What's the least difference, right? So we could really take this further for students that are up for those more challenging questions too. So what's the role of the calculator? Maybe the students are using it to help them, or maybe you're just using it to display the different strategies. Maybe you're displaying accurate ones and also incorrect ones. So you're not the one that maybe says this is right or wrong, but you're displaying it up once students have given you responses, and you're turning it back onto the students themselves. Okay, so do we agree that 5 and 4 work? Do we agree or disagree that 1 or 2 work? Why or why not? What could we change here so that this would be an accurate answer, would fulfill our requirements of the area being more than the perimeter? So a really great question that I think incorporates the area and perimeter side by side, which are two things students can mix up a lot. And then not only are we working with both those, but we have this visual here to really clearly demonstrate and show the differences in the way we might calculate area and perimeter. So that idea of soft language, that's kind of what we just did. That's another strategy, is instead of telling an exact perimeter, we kind of softened the language a little bit and didn't give them that exact one. Here, same thing. Maybe we're going to ask students to find the closest product to 500. So they've got to fill in these different blanks and only use digits 1 to 9. So this is coming from open middle problems. So I should note, slow down for a second, back in our agenda page and our resource page. This is some information just about open questions in general and some of the resources. And these last two that you've seen are from Open Middle, where there's a whole website where you can search by grade level and content of some of those types of questions. And also, as you get exposed to them, you can kind of create your own that might be effective with your students. But we might ask students just to get the closest to 500. So what I like about this type of question is you're inviting everyone to play. It's almost a competition with themselves, right? So if they're having trouble, getting started, just take any numbers 1 through 9 and fill them in. You could just do 1, 2, 3, 4, right? Figure out what that product is. Okay. Now, can you adjust one of those numbers to get closer to 500? Okay, can you adjust another one, or can you adjust it again? Can you get closer? Can you get closer? Can you get closer? So it's not just getting one answer. There are, I guess, what I would say, degrees of accuracy here. So, students are in a way, like I said, competing against themselves, and they're able to be successful even if they don't get the closest of the entire class. But does feed that competition too. So it also encourages students to get a little competitive with what they're doing. Um, and here's where, when I think about the calculator, how I might fit it in is scaffolding. So with the things we're doing as we start to get some of these higher level thinking questions, these open questions, um, there's two things I like to think about my student has to be able to handle. One is, and a lot of these is the computational skill, right? And we want them to be fluent with their computational skills. There's also just understanding the task and the structure of the task and coming up with different strategies. So for me, sometimes we focus so much on developing students' computation skills, or even at the high school level for me, like algebraic skills, like those procedural skills. And we don't feel like our students can get to those higher level questions until they're very, very fluent. And so we don't really give them access to those questions. And I think what we can do though is some students, they can develop that fluency before we get to those higher level questions. But other students, they might develop it even after that. So what I might do with this question is we're going to do it multiple times on multiple class periods or multiple days, and we'll change what the target product is. But the first time I do this with students, I'm going to allow them access to that calculator, right? Or just a similar question. It doesn't have to be this exact question, but a lot of times I give students that calculator first to lighten that mental load. Like, okay, let's focus on what we need to do. And what strategies are going to work. So through using the calculator, through playing around with the numbers and being able to see, okay, what happens when I change the hundreds place, the tens place, and they start to see different patterns of what's going on, make different connections and come up with their own strategies. Then maybe the next time we do it, we take the calculator away. So they have that foundation of problem solving strategies, and approach. And now there can be more focus on the actual skill of computation, and they can get better at their, okay, in this case, multiplication skills. So that's just something, an approach I take with a lot of different topics with my students is I'm not going to be afraid to give them the calculator at first, and then maybe take it away from them once they're comfortable with the types of questions I'm asking them. Another way to open up questions is just what if, okay, or ask something like, would it be possible? Why does this happen? What do you notice? What do you wonder? So we go back to Melanie and her coins. She's got those 48 cents. We could add in the question, well, would it be possible for Melanie to have, I don't know, 2 quarters? Why or why not? Right. So you could just give any combination of coins. Is this possible? For Melanie to have this combination. And so we extend that discussion again in a lot of different directions and allow students to think about it in different ways. And what I really like about this is I've found that the more I ask these types of questions, the more I get students asking them to me. They'll be like, well, what if we'll be doing a problem? Like, well, what if we change this? Well, what if it were this? And they're starting to think about different cases. And so they're getting creative with it, and they're thinking beyond just what I'm giving them. So that's really cool to see as you ask those types of questions that your students see you modeling that, and it kind of becomes contagious a little bit. Really, you start to see them become curious. Here's where we could just display something, right? What do you notice? What do you wonder? And we could use the calculator to display something like this. We've seen this a few times. We're looking for patterns, right? What do you notice? What do you wonder about the pattern? Put it in the calculator. Let them get exposed to it. Let them see you pushing those buttons, right? They're going to get more familiar with it, more comfortable with it, the more exposure. It doesn't have to be them directly using the calculator to be learning. It works great again for that notice and wonder. Here's some visuals, not just the numerical representation, but we could go back to the numerical representation within the calculator as well. So the more representation students are seeing, the better. I put in here, ask for similarities or difference. So not just notice and wonder. A lot of times my question is what's the same, what's different? So they might be comparing these 2 pictures or these 3 figures here. What's the same, what's different about each of them? And when you ask those really open questions too, they don't have to give mathematical answers, right? So it allows everyone entry into that question to talk about, well, maybe they just notice the colors, right? That's great. Start with that and build off of it. All right, then the last strategy of creating open questions is to leave certain information out of the problem. So I pulled this again, these questions that you've seen up here for the most part are from your end of grade sample questions. And so here I just removed another piece. I said, you know what, I'm not going to give them what's on the left side of the equal sign. So all of a sudden, this opens up a lot more possibilities for correct answers. Is going to invite creative and unique strategies, and it's going to help us enrich in those conversations about connecting multiplication and division. So I'm keeping the language of the question. They're still going to be kind of familiar with seeing this then on their end of grade test, but they're going to be even more flexible in their thinking when we are done with talking about this question. Differentiation, we can allow students, like maybe they can just come up with 1 and 30, right? But what a great answer. I think if sometimes the simplest answer isn't exactly the easiest answer to come up with. And a lot of times my strongest students will overlook that simplest answer. And when I say strongest students, I say the ones that usually kind of score better on tests and quizzes and, kind of just perform better in the math classroom. But a lot of times those students that can be more creative can find those simplest ones. Or I call them my lazy math students, but they're working smarter, not harder, right? So just come up with 1, right? 30 divided by 1 equals 30. Something that might come up too is maybe someone tries to throw 0 into one of those spots. Or maybe you could encourage, like, you could ask the question, could I put 0 in either of these places? And think about the discussion you could have about division and 0. If, there might be some students that are ready, depending on where you are with them, that to have that discussion. That doesn't come out right with the closed question. Right? We can't take all those different avenues with a very closed question. We need to open that question up to see where our students might take it, or maybe we kind of nudge them in certain directions too. And again, this would be one that maybe we allow students to use the calculator, maybe we don't, right? Depending on what we want our students to be practicing. Maybe we give this type of question multiple times. The first time they have that question so they can quickly get those answers and start to maybe work out relationships between division and multiplication and factors and things like that. Or maybe we're just using it to display answers. We might not even say whether they're right or wrong, right? Or we could look through and again see if students disagree or agree with the choices. And maybe even see some creativity. We never defined that it had to be integers, right? So maybe students come up with non-integer answers, and we can reward that creativity and celebrate it too. Here's another question that's very closed, but we can make open just by removing the answer choices. So we can give them a fraction, this circle, right? We can give them this picture and just ask them to come up with another picture that's an equal fraction. So we start this problem, students are working just with that picture and that representation of the fraction. And we can encourage students and challenge them to come up with more than one correct answer and see how far students can get. We can celebrate the student that gets 1. We can celebrate the student that comes up with 5 different ways. And then we can bring in the calculator and we can start showing the numerical representation, right? And maybe we can start to see some patterns as we display student responses, and we can display them in a certain sequence that will encourage them to start to see some patterns of equivalent fractions. We could even continue this pattern and then maybe ask for what might come next, right? So 1/3, 2/6, 3/9. Okay, what would the next fraction be if we're increasing? What would the next equivalent fraction be that we could come up with? We could challenge them. We could give one part of the fraction. What if we, put the 45 in the denominator and ask them for the numerator? And what if we put 9 in the numerator, ask them for the denominator? So there's a lot of different directions we can take this question in our discussion. There's a lot of different ways we could use the display of the calculator to encourage students to see those patterns. We could also have, as I said, the students working directly with the calculator to help with those patterns too. again, I think the supporting of representations is important. So we started with the circles, right? That picture, and we're supporting it with the numerical values then, and making those connections and letting students see the patterns, let students tell us the connections, and let them kind of verbalize it instead of us just telling them. Here's a number line. I would basically remove everything here. I would just keep the number line and maybe Z, pick Z, and just ask students, what's this number? Right. So what I would be hoping for then is maybe two different students come up with these answers. Right. Someone might even come up with a third one, 0.75, right? Maybe I'm giving them a calculator and they could come up with any of those representations. And then I would put them all up. I wouldn't say who's right or wrong. I would ask my students who's right or wrong. So I love that opportunity in class when I've asked a question and multiple students give correct answers that are represented just differently. So I can say who's right, who's wrong, and they're all right. And so sometimes students get uncomfortable with that because a lot of times in math class, right, there's only one right answer. They can't all be correct, right? And who's to say any of those are a better answer than the other one? They're all equivalent. So we can talk about equivalence. We give students the opportunities to come up with those. And that's something that I think is a lot more powerful in class than, me telling students, hey, 3/4 and 6/8 are equivalent. This is why. But it's coming up more organically with this problem if I ask it as an open question. Maybe, again, I get some students that give me 3/4, some students that give me 6/8. Okay, why are they the same? And that's a lot more powerful when it comes up in that organic way than just telling students they're equivalent. Here's one we can just remove again the answer choices. Come up with a rectangle that has the same area. And they could be drawing these, and then we can bring in those numerical values. We can start to see patterns of what's going on here and connecting to the idea of area and how we find area. For this one, we could remove information again. So I'm going to remove the answer choices. I'm also going to remove the 40 degrees. So as they approach this question, instead of just being one answer, they can come up with multiple combinations, right? And really there's an infinite amount of combinations that could fill in to those two angles to make them add up to 90, right? So that's the key. They have to add up to 90. But I'm not going to tell them that, right? I'm going to just display their answers. So maybe I get some correct answers and maybe I get some incorrect answers, but I can just display them all at once before I even give them the feedback of you're right, you're wrong, and open it up to the class of, okay, who's right, who's wrong, who do you agree with, who do you disagree with, and why? And so we could have some conversations. And maybe people even might disagree with 85 and 5 because it's, oh, that doesn't look like it could be 85 and 5, but maybe it's not drawn to scale. So we could have that discussion too with students. The other thing that can happen here that I really like is as I'm putting correct answers, maybe there was a student that was sitting there and couldn't get the answer. But now they see the pattern, they see the strategy. They haven't been told directly. I'm just starting to show the different combinations. And then on their own, they can come up with their own unique answer. That doesn't happen with the closed question. Once we reveal the answer to a closed question, like the thinking's done. Like, okay, I got it wrong. This is what it should be. But here, it gives the opportunity for that student, again, to come up with their unique answer. They can still feel good about themselves, right? That they figured that out with just a little bit of help, not being told directly what they needed to do. And I think that's really powerful. The last one through here is volume. So again, we could just consider the dimensions, give them what the volume has to equal, ask for the dimensions and see the different combinations, and we can talk about connections between these different responses that we're getting as students share. All right, as we come towards the end, I did have two questions that you could use the graphing calculator for. Obviously not students using it to solve the problem, but these types of topics to get them ready for. Here they were creating a trapezoid and the other one was looking at a pattern of points. So I just threw this in here just to make sure, like, don't be scared to dig into the graphing calculator a little bit if it might support, some coordinate problems. I think these were 5th grade, but I saved these graphs here So they're built for you if you wanted to kind of dig into them. Again, we're not focused on the graphing calculator here, but students wouldn't have to do anything over here. We just, okay, how do we drag this point to create a trapezoid? Is there multiple ways to create that trapezoid too? So just kind of that dynamic graph and that clear visual for students to really play around with and see could be helpful in deepening their understanding of that concept. And the other one was ordered pairs. So I even sometimes project this on directly onto my whiteboard so we can kind of draw on the whiteboard and it will show up. So you could hide these points, have students plot them, and then we can check if they show up in the same spot. And then we might start to look at the pattern here and extend the pattern out with those points and see what strategies students come up with for extending that pattern. So again, I gave you those links and just encourage you to not shy away from maybe digging into that graphing calculator if you're comfortable with it. And then the last piece here, as we wrap up before for checking in for questions, are those technology enhanced items. So I pulled a couple of those. And one thing that stands out to me is, students are going to select or click multiple answers here. The way they're listed really matches the way we've been displaying some of the patterns and the strategies throughout all these open questions. So if you are doing this throughout the year, here and there, of okay, here's an open question, right? It doesn't have to be every day, right? They've seen things listed out like this. They've seen, okay, different ways to make 16 with that notation. They've seen different ways to different strategies. You've shared different strategies that students have used to find the area of a rectangle, right? You can have that open question, that discussion, and display all of these within the calculator. Obviously the correct ones when you're doing it, but that format of those technology enhanced items are really familiar to our students if we've been using the calculator to display their own strategies throughout the year. All right, so I feel like I'm doing pretty good on time. So I'm gonna stop and see what questions we have, and I will hang out here for all those questions. But as I do that, I would love for you all to just take, I think it's 4 questions, to share feedback on today's session. So as we design these for the future, as there are things that you want more support with, we'll be happy to do that for you either just through Desmos or in collaboration with North Carolina. So, and as Beth said too, like we've done webinars and they've taken feedback. Both North Carolina and Desmos have worked together to add that button, the fraction button, and the convert to decimal, convert to fraction toggle back and forth. So your feedback is super important, and it's definitely taken into consideration as we move forward to support you all in the classroom. So that link, I think Beth threw in, but it's linked in the agenda here and at the top. So hopefully you can get that survey. And I'll kind of step aside and see what questions we might have.
All right, so we have one question. If we can go back to the calculator, some clarification on clearing a line versus clearing all.
Sure. So there's actually kind of 2 buttons here. So this X that's pointing to the left, that can clear just like one character at a time within that line. This clear button, the first time I push it, will just clear that line completely. So I don't want to have to keep going, clicking this one character at a time. If I click this clear, it will clear that entire line, but these other lines are still there. Once I've cleared one line, there's nothing to clear in that line. It prompts me now clear all. That button changes to clear all. So I click it a second time and the whole thing clears out.
Awesome. And the only other question that we've had pop in a few times is accessing the recording. Um, it'll either be late today or tomorrow. Everyone that registered, whether they logged in today or they couldn't. I know this is a hard time, especially for those of us who are parents and are juggling our kids' stuff. Anyone who registered will receive a recording of today's webinar, as well as links to all of the slides and the featured calculator and the agenda. So please be on the lookout for that. It does come from NC Public Schools, so sometimes it'll hide in your junk box, but you'll be able to share that with anyone if you had a PLT member, for instance, that wasn't able to join, and there were some things you wanted to share with them. As we finish up today, just a quick note again about contact information. I am Beth Nash. I primarily work with our middle school and high school um, math and science, but you can always reach out. My counterpart, Michael, his email is there, and email either of us, and you'll get both of us because we work as a team. And then there is Nolan's email address. I would like to thank Nolan. I know we gave him a big challenge this year about updating content, and really we know our middle school and our high school teachers just love Desmos, but calculators are not as often used at the elementary level, and I think he did a really amazing job today trying to make some connections and some excellent strategies. So thank you for that. And with that, we will sign off for today. Please check your emails for the recording, and we hope that you do reach out if you have questions either about Desmos itself or if you have questions regarding check-ins or EOGs. You have our contact information. We're here to help. All right, and thank you, everyone.
Thank you all. Thank you, Beth.
Thank you.